All right, good morning. Welcome to FOR 242. Glad you're with us. And we are today looking at a comparison between a cruise and a full inventory from LiDAR. Of course, we're not actually going to send you out into the woods, but what we're going to do is generate some random points that would be inventory plots, and we are going to extract the value for those inventory plots from each of those 5 locations. So the first part of this is to calculate the total value using saw log volume and total gross merchantable volume. And that's going to be done in a familiar way to you. So we're looking at the pulp, which you did 2 assignments ago, the saw log, which you did 1 assignment ago. And in this exercise, we're going to take the total volume minus the saw log volume to get the pulp volume. Because of course the saw log is the saw log, gross merchantable volume is the total, and what's left when subtracting one from the other is going to be the pulp. So after that, you're going to end up with a total value, so that's the total stumpage value for the entire thing. And from there, you will then do the fake cruise. And at the end, you're going to ask the question, is this cruise that I did with 5 plots representative of the stand as a whole? And for some of you the answer will be yes, and for some of you the answer will be no, depending on the type of stand you've selected, whether the stand is homogeneous or not. If it's half of it's softwood and half of it's hardwood, that's of course not going to work out very well. But 5 inventory plots for an operational block is reasonable. Might be a little bit high or a little bit low depending on who you're working for. If you're working for a private landowner, 5 would be low. If you're working for a large industrial landowner, you would be hard-pressed to get 5 done before going on to the next thing. So depending on your situation, this might be high or low. But we are going to work with the same data as before, and that lives in the same place, which is the lab area. And that is the Jeff Dubas Memorial. So there we go. We'll open that up. And to begin with, I'm just going to select a stand based on visual interpretation of the boundaries or of the forest inventory. So I'm going to look for some area of high saw log volume. And of course, remembering that these data are out of date. This is a 2015 inventory, and there have been many operations in here since. But let's go ahead and pick one out. So last time we worked in the south. This time we're going to work in the north, and that is a fine looking stand there. So I'm going to select by polygon. And let's see, I want to go from here to here to here to here. And we'll try that. And I don't like that, so I'm going to selection, interactive selection method. Remove from current selection, and I can just click. Oh, now it's sad. So I'm going to use the select by lasso there. Draw that and remove that from my selection. Now I'm happy enough with that. So I'm going to go ahead and export that. So right click, data, export data. And I'm going to send that to my discard folder as operation inventory. So the inventory for the area that I'm doing this operation. So that is that layer that I'm going to be working with, and I'm going to dissolve this so I can get its complete area. So geoprocessing, dissolve. Input feature is operational inventory, and I'm going to call that operational bounds. Once it gives me the chance. So operation boundary. And okie dokie. So now we have that. I'm just going to give that a nice red outline. And the first thing I'm going to tick off this list is the area. And that is the area in square meters. and I want that area to be in hectares. There are, of course, 10,000 square meters per hectare, so that's looking like a 5.5 hectare. So let's add a field. So let's drop down here, add field, type double, name hectares. Right click on hectares header here and calculate geometry. Units, hectares. So there you go, 5.5 hectare block. So that's that. So what are our next steps? We need to calculate the saw log volume. We need to calculate the pulp volume and their respective values. So let's look at the instructions again. So I need, let's see, 4 new fields. So I need hectares, saw log cubic meters, saw log 1,000 board feet, and saw log value. So this is familiar from the last operation here. I'm running the math out a little bit differently to help prevent running into that issue of forgetting to incorporate the fact that these inventory data are in a per hectare form, and we need to get a total for each cell. So let's pop back in here, and I'm going to open up the properties here. So right click, properties, and here I've clicked on the wrong one there. So I'm going to now right click on operational inventory, and now I have all of these extra fields. I'm going to turn them all off. I'm going to include the feature identification number, the gross merchantable volume, and the saw log volume, and that's all I'm going to include here. So now when I open up this attribute table, right click, open attribute table, I have the gross merchantable volume and the saw log volume. And now I need to create 4 more. So I need hectares, saw log cubic meters, and then saw log 1,000 board feet and saw log value. So let's start cranking out these new fields. Add field, type double, hectares. Add field, type double, saw M3 for saw log cubic meters, and that is the actual volume within each cell. So this is the saw log per hectare value. This is where we're going to calculate the actual size of the cell, and then we're going to calculate the total saw log volume, which is that times that. And then add another field, so saw MBF, and that's again going to be type double, okay, and finally saw log volume, or value. Saw log value, which is going to be type double again. So there we go. So to calculate hectares, same as before, right click on hectares and calculate geometry. Units, hectares, okay. All 0.39977. If you had clipped this layer, some of these would have been different, and that would make this step important. But to confirm we are working with the same area, we can right click and ask for statistics and see that 5.516847, that is exactly the same area as the area of the operational bounds. So that is that. Let's see, do we have any that are different? Nope, we're good to go there. So now saw log cubic meters, that is a field calculator operation, and that is the saw log times the hectares. Okay, so now this one has 7.147914. That's a misleading kind of precision there, but that is good for carrying on into the next step of this calculation. If we rounded that off, we would have introduced undue error. But we do need to remember that this is a way more decimal places than this figure deserves. So now saw log MBF, that is field calculator, and that is going to be saw log cubic meters times 0.424. I'm going to check and make sure I'm got the right number there. Yes, I do. And that's that. So here we go. And now I need to work out what the actual stumpage value I'm working with is here. And it's either going to be hardwood or softwood. And I'm going to turn on my color infrared air photo, turn off that, and see that is definitely a hardwood stand. So conifer here, hardwood here, conifer here. If you've picked a conifer stand, you'll use a different stumpage value than the hardwood stand. And again, let's look at our stumpage report, which lives here, which I've already downloaded twice here. So let's use Aroostook County because that's where we are. And we are looking at sugar maple stumpage, 2018 average. Let's use that, which is $159. So $159 per 1,000 board feet, MBF here. And let's pop back in here. Open up our attribute table, check that back on, check the air photo off, open the attribute table, and use the saw log value field here, calculate its value with the field calculator. That is saw MBF times 159. And that is that. So that saw has $481.88.3 cents. So $482 worth of wood in that 0.39977 hectare block. And the total value of saw timber is, let's see, $55,000, 666.475845. So a pretty penny. Enough for your truck at least. So we'll clear whatever selections we have there. And now, what is our next step? We've finished the first task here. So the next step is to calculate the pulpwood volume and then apply a pulpwood value, in our case, hardwood pulp. And I'm going to actually remove that so we know what we're working with. So if we're calculating hardwood, we'll use this conversion factor. And if we're calculating softwood, we'll use this one. So there, so we need 1, 2, 3 new fields in our attribute table. Back in here, open the attribute table, and I'm just going to make those a little bit smaller. And I can just double click on that just like Excel, and it makes it fit. Unless it tries to sort from smallest to largest because it's silly. All right, so now new fields, and that's pulp cubic meters, pulp tons, and pulp value. So let's add the first new field, pulp M3, and that's double. Add another one, pulp tons, that is also double. And finally, pulp value, and that is going to be type double as well. So pulp cubic meters is going to be field calculator, and that is going to be just like the other one with a slight difference. So we need to write the expression, open parentheses, GMV minus saw log times hectares. So GMV minus saw log, the remainder of that is the pulp, so if it's not saw, it's pulp. And then we multiply that by the hectares to give the total value in cubic meters. So we're cutting one step out there, but that's fine. So, okay. So we have 2.9 cubic meters of pulp. So we started with that, and that looks about right there. So we have more saw timber than pulp, which is good. And then we need to convert to tons, and our conversion factor is here. And let's see. So pulp tons equals pulp cubic meters divided by 1.43 if softwood or 1.25 if hardwood. We're in hardwood, so we're going to divide by 1.25. So field calculator, delete the old equation here, and we have pulp cubic meters divided by 1.25. And I'm just typing in that 1.25 there. Okay. So we have 2.389035 tons. And tons is something we can work with using our stumpage price report. And we're going to go for the mixed hardwood price, which is a whole whopping $8 a ton. So back to here, pulp value, right click, field calculator. And that is going to be pulp tons times 8. And that means that there's about a whole $20 worth of pulp in there. Statistics for that, we have $2,466 worth of pulp coming out of that harvest. So the saw logs is obviously the reason why we're here, but $2,000 worth of pulp will pay for half a summer student, so that's worthwhile. And now we need one more field here, so I'm going to shrink these down so we can see. And now we need a value total. So add field, value total, and that is again going to be double. Why not have all the points here? So it doesn't like that name because it's too long, so it's going to be value tota instead of value total. So now right click, field calculator, and the total volume is just going to be the saw log value plus the pulp value, which altogether makes that. And let's find out what our total is. That's $58,132.83. So all that is a pretty penny, and that is what it is all worth. So I'm going to write that down. So let's look at that again. So that's 58,132.83. And that is the true total. So there is going to be some error in that estimation. So all of this, of course, relies on check plots, or I forget the word, calibration plots. So the calibration plots that were originally done to say that when the LiDAR sees this, this is what it means in terms of inventory on the ground. And for however many calibration plots you have, there's always going to be some cells that are a little bit high or a little bit low. But the ideal is that on the average, they're going to be accurate. So one might be high, one might be low, but put those two things together and they come out in the middle. And let's see, so that's where we are. So what we're going to do next is generate some random points inside of here. And we're going to use those as if they were forest inventory that we actually went out and did. And then we're going to sum that all up to a per hectare average. And then we are going to go ahead and calculate the total value from that. So search for tools, generate random points. And just like you were generating points to actually do or create random points, sorry, still there. And the application is there. The constraining feature class is going to be the operational boundary. And let's see, that just wants a name, so that's going to be plots. And we want to set the number of points to be 5. Everything else can remain the same, okay. And here are my plots. When I turn them on, there they are. And now I can use the information tool, or the identify tool, and click on the cell where that one falls within. And you see it's caused that issue where it's wanted to select from the one that's on top. If I want to change that, I can scroll down and see I want the operational inventory. And now I can click again, and here we go. So we have the total value of that. And let's see, how are we going to deal with this? Because this is a total for that cell, and that cell is 0.39977. So we're going to have to calculate a little bit again. So let's see how this works. See if I can get this right on the first shot for you. So we have 470.86. And now we are going to divide that by 0.03997 to get a per hectare value of 11,778. I did get that right. So we don't need to do that step yet. First, we need to get an average of these total volumes. So I'm going to write down every one of these. So 470.86. Go to the next one and make sure I'm just getting one. And that's 443.80. That's 456.41. You see I'm rounding to the nearest penny here. And we have 470.19. And finally we have 443.37. And now I'm going to take an average of those. So we have 470.86 plus 443.8 plus 456.41 plus 470.19 plus 443.37 equals, and then divided by 5 equals 456.926. And that is the average value of those 5 cells that happen to intersect with those points. And what that means is that if we then divide by 0.03997, it is an average of 11,429.72 per hectare. So you see how this has converted it back to a per hectare value. And if we go back and look here, we'll see that we have 5.517, around 3 there, hectares. So that per hectare value times 5.517 equals 63,057.78. So that 63,057 is compared to 58,132. So let's subtract that. So 58,132. So we were high by about 5 grand using an inventory of 5 plots. So this does not reflect the actual variation on the landscape. This is a calculated total. So the estimated value here is known, which in a normal forest inventory, the actual value is not known. So this is as close to a real comparison of known total versus estimated total as you could get. If you actually went out here and did an inventory plot, you'd probably be off more, because this is taking that whole 20 by 20 meter cell as its plot and trying to scale that up based on these 5 plots to this whole stand. And let's look at some of the reasons why this might have been high. So we'll go by quantities. I'll just say show by the total value, where, oh no, that's pulp value, I'm sorry. We want value total. There we go. So it looks like these 5 plots have just happened to land in some of the higher value areas. Some of them sort of in the middle, but all of these lower values in this edge area were not incorporated into those 5 inventory plots. So in this case, we estimated high because the plots happen to land in the more heavily wooded areas. Let's look at how that looks on an air photo. So here's the color infrared. Let's go ahead and zoom that in there so you can see a little bit better. You can see so lower value in here and around the edges, and you can see a lot of big canopies in here, and you can see a lot of smaller canopies in here. So that makes sense. These are bigger, older trees. So conclusion, we overestimated by $5,000, which is a lot. So $5,000, let's be rough here, divided by 60,000 total, we're off by about 8%. It's a whole awful lot. $5,000, that's a cheap summer student. So hopefully make more than that in the summer if you have work this year, but the amount of error that you're off with here could fund summer employment for one of you. So to put that in perspective, that is what that costs, or could cover all the gas and vehicle expenses for a summer, or pay for any number of things. So you definitely don't want to be off, and this shows, assuming the LiDAR inventory is accurate, the value in knowing exactly what you're going to get. Because say you, in some parts of the world, you bid on a forest job based on what the inventory says. If the inventory is low and you get more than you paid for, wonderful. But if the inventory guesses high, as it did here, you're short $5,000 and there's nothing you can do about it. So that's a really unfortunate situation that is often correctable through the use of LiDAR. And I know in British Columbia, where I was before, they've made a huge switch in that way, and that's one of those places where jobs are bid on. So that kind of predictability goes a long way towards keeping people in business, because if they can count on this being a $58,000 stand and not a $63,000 stand, they can plan accordingly, put the appropriate machinery in, make an appropriate bid, versus a stand that might come up short based on inventory. Even if you were thinking about bidding on it and went out and did your own inventory, if you could only do 5 plots, you might guess low, and then you have the same problem, or guess high and have an even bigger problem. So there is sort of a forest inventory lesson and a LiDAR operational lesson 2-for-1 deal. And that, I think, let's just check and make sure I've got all this. So first task, second task, and third task, I've done that. So now you just get to make a grid and have another lunch soda and get all that done. So that should keep you busy for a little while, and I think that's all we have to say about that. Hope you're all doing well. Glad to have you still following along here. Shoot me any questions as always, and stay healthy and safe. Until then, hope to see you soon. And we have a helper here. Hi, Daisy. Come on, girl. Daisy wants you to study hard. All right, catch you later.